Okay, so welcome back, and now we're going to do an example with 3 parts. And so in these examples, we're going to look at the limits at infinity. Okay, so with the first one, we have f of x equal to 5 minus 2 over x squared. So this is a reciprocal squared function. And so what we're going to do is we're going to use the limit laws. So this applies to this. So we're going to take the limit as x approaches positive infinity. So the limit as x approaches positive infinity of 5 minus 2 over x squared equals, well, this is a constant, this is a function, so we can distribute. So it would be the limit, well, the limit of 5 is just 5, right? It's a constant, so we can use the constant law. So this is going to end up being 5 minus the limit as x approaches positive infinity of 2 over x squared, right? And so then we can also do the limit laws here. So again, but we don't have to, because at this point we can just ask ourselves, what happens to this as x goes to positive infinity? Well, the denominator is getting big, the numerator is staying the same. So this fraction is getting smaller and smaller and smaller. So as this goes to positive infinity, it's going to 0. Okay? So this equals 5 minus 0, which equals 5. Now similarly, if you have negative infinity, then you're getting 5 minus the limit as x goes to negative infinity. But then any negative number in here is squared, so that becomes positive, so you end up with the same result, 5. So what this is telling you, that you have horizontal asymptotes at y, you have one horizontal asymptote at y equals 5, and both the graph of the function is heading towards the asymptote y equals 5 in both the negative direction and the positive direction. Okay, so now what about this one? Sine x over x. Now we know the limit of this thing as x approaches 0, right? That's 1. But what is the limit of this thing as x goes to positive infinity and negative infinity? Well, let's see. Okay, well, let's start with sine x. So we know sine x is less than or equal to 1, greater than or equal to negative 1. And then if we divide everything by x like we did before, we get this. And now, because this, we can use the limit laws here and the squeeze theorem, right? So what happens? We get the limit as x approaches infinity of negative 1 over x is less than or equal to the limit as x approaches infinity of sine x over x is less than or equal to the limit as x approaches positive infinity of positive 1 over x. Now, this limit is going to 0. And this limit is going to 0. So by the squeeze theorem, the limit as x approaches positive infinity of sine x over x is equal to 0. And similarly, we can do the same thing. We find that the limit as x approaches negative infinity of sine x over x is also equal to 0. Okay? Now, what about the last one? Okay, so the last one, let's look at the graph to help us with this one. Okay, so you should know the graph of tangent, right? Well, the graph of tangent is defined where? from negative pi over 2 to pi over 2. So we have horizontal asymptotes. And so we know what? We know that it does this, right? So that's the tangent function, which means, remember, if we're dealing with tangent inverse, it's what? It's the inverse function, which means that they are mirror images across, or a reflection across the y equals x line, which is the identity function, right? Which means that if we rotate this across, or flip this across the line y equals x, we get something that looks like this. Oops, let me do it this way. Yeah, let me do it this way. So this is just going to be a sketch. So this is going to be at y equals pi over 2, y equals negative pi over 2. So if I flip this, what happens is now I get something that looks like this. Right? So basically it just flips and now it looks like this. And so what happens? If I go to positive infinity, it's approaching y equals pi over 2. If I go to negative infinity, it's approaching negative pi over 2. Okay? So again, you can deduce this by looking at the graph and saying, hey, as x approaches pi over 2 from the left. Okay, so there's two ways to do it. You can look at the graph and deduce from the graph that, hey, since this is a reflection across y equals x, I get this, and then you can determine, hey, what the limits are. Or you can look at tangent x, so this is tangent x, so this is f of x equals tangent x, and we'll call this f inverse of x, right, which would be tangent inverse of x. Okay? So now, if I look at the limit, so that's one way, right? But if I look at the limit of tangent x, right, for a moment, as x approaches pi over 2 from the left. Oops, not negative pi over 2. Over. So pi over 2 from the left. So that means I'm approaching pi over 2 from this way. Well, what happens? Well, I see that the limit as x approaches pi over 2 from the left is going to positive infinity. Okay? Which tells me the limit as x approaches positive infinity of tangent inverse of x has to equal pi over 2. Because the fact that they're inverses of each other. So look what I did. I just flipped the 2. Right? And similarly, if I approach negative pi over 2 from the right, so now I'm going this way, right? What's happening to the graph? I'm going to negative infinity. So that means the limit as tangent inverse, the limit as x approaches negative infinity of tangent inverse of x is going to be negative pi over 2. Okay? So there you have it. Those are the answers. Have a great day.